perform a command injection, SQL injection. And I've just got some demonstrations here so you can practice doing it by hand. The pros use SQL Map, which does it automatically, which is fine, but you might not understand what you're doing. So, as teachers always do, doing it yourself the hard way is often good for instruction. So, I'm going to set up a page with a few SQL databases. So first I reset the server. All right, and what you're going to do here is you're going to be able to do command injection, just like those other challenges. But the problem is the commands you're injecting are in this language, SQL, and many people are not familiar with SQL. So in SQL, the administrator has the ability to execute commands down here, like show databases. And that lists the databases on the server, and there are two. This one is always present on MySQL, information_schema, that's automatically created by the software, and it always has the same name, and that is key to hacking into it. Then there's one created by the company, in this case named widgets, that's going to contain the company data. This is just going to contain metadata, but that turns out to be quite useful. So you can show databases, you can also show tables. All right. And it shows you the tables in the default database, which is widgets. So this only has one table called employees. And in order to exploit a SQL database with SQL injection, you need to know the name of the database, the name of the table, and the name of the fields of what you want. And that information is easy to find because it's stored in the information schema, which is pretty cool. Now you also need to do other things. You can do select queries. Selects data from the database. You can actually just select data that's not in the database, like just a 1, and it will echo back a 1. And you can also get strings, like foo, and it will give you a string of foo, and you can combine strings, like concat of foo and bar. So you can combine two strings into one combined string, and all these are going to be important later. Then you can get data from tables. Now star will get you all the data from a table. Select star from employees will give me everything about the employees, their name, their social security number, and their ID. And this is why you never let the customer have access to this kind of field. The customer is not allowed to run arbitrary SQL commands on this database because it's too important. You only let your database administrator do this. You give customers much more limited access to the data because you don't want them seeing other people's social security numbers and such. Now you can also select certain fields, like just the ID, and I could select two fields like ID, SSN, and then I get those two facts for each person. So all of these things are available. I could also concatenate them into one field, and I could restrict it to only a certain employee with a where clause, which we're going to use. So now I select name and ID from employees where ID equals 1. So now I get just the information about this one person, and this is what's underlying normal things you do, like read your email or go to your profile page on Facebook. You see your data, nobody else's data, because you're running a query which is put there by the administrator, and it has a where clause that lets you see only your information and nobody else's. This is what's really going on. All right, now you can insert data into the database too. I'm not going to bother, but you can. And so now, if you were trying to hack into a server and you don't know the names of the databases, tables, or fields, which is the normal case, then you query into these automatically generated tables. So if I try to get everything from information schema tables, I get a list of all the tables there are. And the ones in capital letters are the automatically generated ones. And in this case, the ones created by the user are going to be, created for the company, are going to be in lowercase. They'll come up later. So here you can select table name from information schema tables. This will give you a list of all the tables available. And you get a long list of all these capitalized ones. And then at the bottom, the lowercase one is the one that actually contains company data, not just metadata about the structure of the database itself. And you can get all the columns too. Select column name from information schema columns. And in this case, it's easy to tell them apart because the column names are all in capital letters for the automatically generated columns, and at the bottom, in lowercase, are the columns in the thing that contains company data like ID and social security number. So, all right, and of course you can restrict it. I could get the columns for the table named employees. With this, I select column name from information schema columns where table name equals employees. So that'll get me just the company data and not all that other stuff that I might not care about. So that's just a few useful SQL commands, and we're going to come back to these, but the point is these commands you can't use normally because you don't have access to this kind of input field where you can execute commands on a database. So there's a couple flags to find with that stuff. When you see this line, you're entering a different database. So don't use a field up there to answer a question down here. You have to use this field. Now, on a real case, like a real social network, you would never get that field. What you get is a field like this. You could look for users. So I can look for, say, Bill, and when I submit, there is nobody named Bill. So I don't get any result. The query is a valid query, it just has a result of 0 rows. Now there is a guy named Bill Gates, however. So if I give the name correctly, then it finds Bill Gates. So that's nice. Now, if I give somebody that isn't, now if I give somebody with an apostrophe in their name, that's what reveals the vulnerability. Tip O'Neill. Now I get a syntax error. This should never happen. If I put in data, it should look for that data in the database. If it finds it, it should tell me it found it. If it didn't find it, it should tell me it didn't find it. Under no circumstances should I create a syntax error. The reason I created a syntax error is this is the line that was created. Now this part of this line was written by the developer. Select name for employees where name equals, quote. The user only controls what's inside those quotes. All the rest is controlled by the developer, and the intention was I'm not allowed to crash the server. The problem is, once again, they made the same mistake. They used this language PHP to create a line of text in a different language, SQL, and then handed it over to a processor to interpret it as SQL. This is the same thing that always leads to command injection. In this case, they put in an apostrophe here, intending it to match this apostrophe here, but it did match this apostrophe that I put in. So now, it looked for the name Tip O, and the next word is intended to be a command from the developer. So I'm now able to inject commands. It's just that Neil is not a valid command. That's why it crashes. So I just have to put in something more careful that will put in a valid command, and here's one that will do that. If I do this, now I get everybody's name because the name I put in was that. And this was interpreted by the server as the name is Sam or 1 equals 1, and the pound sign is a comment, so it eats up the missing apostrophe at the end. So it's not a syntax error from having the wrong number of apostrophes. So now the where condition is a compound conditional where the name is equal to Sam, which never happens, or 1 equals 1, which is always true. So the compound condition is always true, so I get every name in the database. So this is pretty good, but I only got names. I didn't get social security numbers because all I did was make the where condition more easily satisfy. I didn't change what was being taken from the database. I'm still using the developer's code here, and that's not what I want. I want to inject code all of my own. So the way to do that is down here. The union command will add 2 select queries together. So now, if I run this one, I get a result of 1 because now it runs this select query, which looks for somebody named Sam and finds 0 roles. Then union means add another query, and the second query does select 1. So now I'm able to put any select query I want here. So by doing this, I have taken this input box and I've turned it into this one. I can now execute any SQL command the way the administrator could. So I could take one of the ones up here, like select column name. I want to get a name of all the columns in the database. I could take that and put it in here. I can run any of those things, and there they are. So down at the bottom, I'll see there's an SSN and PW column available somewhere. So there are social security numbers and passwords available. And I'm going to have to find the name of the table, name of the database, name of the table, and name of the fields to get them out. But I can do it. Now I've got administrative control over the database. So there's various flags to find here. And if you have a Linux machine and you want to use it, you can use SQL Map, which does this all automatically. And I have a link here to an old project I wrote which shows you the steps to do this same sort of thing with SQL Map. If you run SQL Map, oops, let me see if I can open my SQL Map challenge. Oh, that's the wrong one. Here, there. So here, back in the old days, I used to use Kali to do this. So first you use SQL Map -u to just determine the vulnerability. Then you can use this thing to find the databases, to list all the names of databases. Then you can find the names of the tables. Then you can find the names of the columns. And then you can dump out the data you want. You can also use more automatic ways to just dump out everything. That's why most of the pros use SQL Map once they understand the process. But anyway, I think it's quite fun to do it without the help of a tool, especially the next part. The next part is blind SQL injection. All of those had data that was presented on the screen that came from the database. But this doesn't. So I'll reset the server here. And now I'm going to search for Bill Gates. And this is another database, and there is Bill Gates in here. So I submit, and it found Bill Gates. So this looks pretty good. But suppose if I look for X, a name that's not there, then I get no result. So far, it looks the same as the previous one. But it's not. If I do this injection, which is one of those ones that should dump everything from the database, then here's the query that results. I put in this name, X apostrophe or apostrophe A equals apostrophe A. This eats up the apostrophes at both ends. The compound condition is name equals X or A equals A, so it's always true. So I should get a list of all the users. But what I get is it repeats back what I put in. This data did not come from the database. This data came from my request. So I do not get any data from the database at all. And that's a problem. I can run query, I can execute command on the server. This OR was interpreted as a command. So I do have a SQL injection vulnerability. I can execute code on the server, but I cannot see the results. Now remember that Drupal page where you had to move the results into a file somewhere and you can only use a file once. It is very common that you can execute commands, but there's not any easy way to see the results of the commands, and you have to run blind. And that's what's going on here. However, I can still get information, because if I change this A to a B at the end, then the name is never equal to X and A is not equal to B, so this condition is false. And if it's false, I get nothing. If the condition is true, I get an answer. So I can get one bit of data per query. And now I play the game 20 questions, where I ask yes or no questions to find out things from the server. So if I want to know the length of the database name, I can put in a query like this, and name equals X is always false, but is length of database equal to 1? Well, that's also false because I got no result. So now I know the length of the database is not 1. Now I could try greater than 1, and it is greater than 1 because I got an answer. So I can try numbers until I find the length of the database, and you can also find alphabetical information. So here is an example to show you that. Okay, so now let me see if I can get this to wrap around correctly. It's going to be rude. I'll just have to shrink the font a little. Okay. All right. So now I select name from employees, where name equals Bill Gates. And since I know it's the name, I could do this for a password, but I'm going to do it for the name so we know what's going on. This starts with a capital B. So substring name11, that is the first letter of the name, equals capital B. So this condition is true. So when I run this one, I get an answer, so it's true. So the first letter in Bill Gates is B. If I made it equal to like C, which is false, I would not get an answer. So now I can pump out names one by one. And by the way, you can treat names like numbers. I can say less than C, and that will be true. It just puts them in order. And B is less than C. That's true. So you don't have to try 26 times. You can split it in half and half and half and get there sooner. So using this kind of logic, you can pump out data like social security numbers and passwords and so on. And SQL Map will do this for you automatically too, dozens and hundreds of queries trying things, but it's useful to do it yourself to see how it goes. So that's what I want to show you. That's the next command injection, SQL injection. And there are many more complicated ways to do it, but this gives you the general categories. Stop this video.